So we're going to go back. This is our last function. Our broad term is rational function. The word rational just means fraction, right? Another name for our parent function, though, is reciprocal function, okay? And this is our parent function right here. Sort of like your inverse variation, but k is 1. That's our most basic inverse variation that we can have, right? And then you're going to notice there's this thing right here. It says where x can't equal 0. And what this thing is, this is called a restriction, okay? We've never had a function that has a restriction in its name, in its equation, okay? And the restriction is just there because it's saying that this function exists except if x is equal to 0. If x is equal to 0, we have like the black hole of math. It doesn't even exist, right? Because if I type in Desmos, if I type 1 divided by 0, it's undefined. Nothing even, it's just nothing, right? Okay. And then all of our friends are back, A, H, and K. They're back one more time, okay? All right, so let's pick this apart, okay? We got our parent function, all right? We can have stretches and shrinks. Vertical stretch, you know that with a vertical. I'm going to write the word vertical in front of this. Vertical stretch, that's when your A is greater than 1. This is all just a review, right? Vertical shrink, or in other words, a compression. You know that more as a compression. That is when your A is in between 0 and 1. It's a fraction in between 0 and 1. And then we have reflection across the x-axis. That's when your A is less than 0, or in other words, negative. Right? This is all review. This is all the same stuff. Okay? All right. Now, the interesting thing comes when we have our translations. So our shift left and right. Okay? Yesterday, we noticed that these functions have two asymptotes, right? There's a horizontal asymptote and a vertical asymptote, okay? So if a shift, I'm going to add the word shift on the end because this is going to get confusing. Horizontal shift, vertical shift, okay? So we all know that horizontal shift is h, right? Well, what kind of asymptote is able to move left and right? It's got to be a vertical asymptote, right? So in this box, I'm going to choose a color, and I'm choosing green. I'm going to write vertical asymptote. VA for short. So when you see VA, that's what that means. And it's at x equals h. It's a vertical line at x equals h. Okay? So that means, and I'm going to come over here with my same color, that h moves your vertical asymptote, your VA. Okay? All right. Now, if I'm talking about a vertical shift, and I think, well, what kinds of lines move vertically? Horizontal lines move vertically, right? So vertical shift, that affects your horizontal, and I'm changing my color now, horizontal asymptote. And we call that HA for short, and that's going to be at y equals k, because k lets things move up and down. So I'm going to draw a little like arrow here, and this is going to move, so moves the HA. Okay, combined, we have all of this. Left, right, up, down, all the things. Notice that there's a restriction your x cannot equal h. Because think of it, if x equals h minus h is 0, right? And our denominator can't equal 0, so that's why that's there. Okay, let's go over how to make the parent function, okay? So we always graph asymptotes first. That's the first thing that you put on the graph is the asymptotes, okay? And if you color code them, you're less likely to get them mixed up, okay? So our vertical asymptote is at x equals h. Well, this is the parent function. So it's at x equals 0. We haven't moved it. Okay? So there's my vertical asymptote. That's at x equals 0. That's the name of this dashed line, right? Okay, your horizontal asymptote is at y equals k. There's no k. So it's right here. That's your HA, and that's at y equals 0. Now, the question just becomes, how do you make the graph? Okay, well, remember the name of this function. The name of this function is the reciprocal function. Okay? So y is going to be the reciprocal of x. Okay? So I'm just going to pick some x's and y's. Okay? If I plug in 1 for x, what's the reciprocal of 1? 1 over 1. If I flip 1 over 1, I get 1, right? The reciprocal of 1 is just 1. Okay, so this point is on the function. Kind of make that point big, okay? Make it like a really bold point. There'll be a reason for that in a second. Okay, if I plug in 2 for x, the reciprocal of 2, 1 over 2, well, that's 1/2, right? So 2 1/2. Okay? Now I'm going to plug in 1/2 for x. So think about this. What's the reciprocal of 1/2? Flip over the fraction. What do you get? 2, right? So when x is 1/2, y is 2. So do you kind of see what's happening there? This graph, this curve, is going to hug these asymptotes right here. I don't need to generate any more over there because it's just going to hug the asymptotes. Now, I didn't pick any negative x's, so let me pick a negative. What if I plug in -1? The reciprocal of -1. Isn't that still just -1? So -1, -1. I'm going to make that a bold point. Okay? And then if I plug in -2, the reciprocal of -2, flip over the fraction, would just be -1/2, right? So when x is -2, y is -1/2. And when x is -1/2, y is, flip it over, just -2, right? So you kind of see what's happening on that side too? We've got another piece, and it is hugging the asymptotes, okay? So each of these things, these are called branches. They're discontinuous pieces of the function. All right, this is a function that we can't draw without picking up our pencil. All the other functions, we could do that. We could draw every single one without ever picking up our pencil. But this one, we can't. There's 2 branches, okay? Now remember I had you make 2 points really bold? These two? That's because those are the ones that when you make graphs, those are the only two that you need to put on the graphs. I call those the anchor points. So I want to identify that. This is the point 1, 1. And this one is the point -1, -1. So when you are making transformed graphs, those are the 2 points we have to plot, okay? All right, now let's get to our domain and range. Remember, domain is all the x's that are allowed in the function, okay? You kind of did this yesterday in the pizza party activity. And y'all said, I was so proud, y'all said all real numbers. And that's like 99.999% right. X can be all real numbers, except for one number. What is the one number that x can't equal? 0. So here's how we say that. We just write x equal sign with a line through it means can't equal 0. And that literally means all real numbers except 0. Technically, there's a longer way to write out the domain, but that's all you need to do, okay? And then for the range, if we look bottom to top, we have something very similar. We got arrows going down, we got arrows going up. So it's all real numbers except one number, 0. So it's going to be the same thing. You're going to write y cannot equal 0. Okay? So this is our basic function. From here, we're just going to be adding an a, an h, or a k, and seeing how that works, okay? Once you get the groove of this, this goes really quickly, okay? I'll prove it to you. All right, we all okay with this before I flip over? Okay. Okay, so let's look at example 1, okay? So this is my function, y equals 1 over x minus 2. So you can think to yourself, what's the transformation? That's h. Is that left or right? I hope we know this. This is right 2, right? Okay, and then there's a little blank here. This is our restriction, right? We need to say this because this tells us that, hey, this thing doesn't even exist if we have a restriction. And our restriction is always x cannot equal h. So what is our h? Is it 2 or is it -2? Remember, h is always opposite what it looks in the equation. So it looks like a -2, it's really a 2. Because if x is 2, then I have 2 minus 2, which makes 0. And denominators can't be 0. Okay? Okay, now, making the graph. Always, always, always do your asymptotes first. Okay? So remember, our VA, if I go back up here, where's my VA? My vertical asymptote is always going to be at x equals h. Cool. So I'm going to go down here. My vertical asymptote is at x equals h. And we already been through our h is 2. So our asymptote is at x equals 2. So we graph that. That's our vertical asymptote. Okay? Then you do your horizontal asymptote. That one's at y equals k. All right? And if I go to my equation, there is no k, right? There is no plus or minus after that. Well, that just means it didn't move. That just means it's still at 0. So your horizontal asymptote will be right here at y equals 0. Okay? Y'all with me so far? Okay. Once you have the asymptotes on there, now you have to graph the branches. Okay? Now remember those anchor points we did over here? 1, 1, and -1, -1? We plot those, but you're going to count them from where your asymptotes intersect. Okay? So I'm going to find where my asymptotes intersect, and I'm going to count 1, 1, and -1, -1. And then from there, I'm just going to draw the branches hugging each of those horizontal and vertical asymptotes. You don't necessarily have to do all the other little points if you just give those two. Okay? Does that make sense? So it's not literally the point 1, 1, it's that you're counting it from the intersection of the asymptotes. Okay? Okay, then we go to domain and range. Remember, x can be all real numbers except for one number. So it can be all real numbers except for whatever this vertical asymptote is. And that vertical asymptote is 2. So x can't equal 2. In range, y can be all real numbers except for one number. And it's that horizontal asymptote at 0. Okay? So you kind of see how these sort of match? It's the thing. It's the deal. And the lights are off. Okay? All right, let's do another one. Example 2. Okay, so this one is 1 over x and then plus 2. So this one is a k, so this is a shift up 2. Let's do our restriction. What can x not equal? X cannot equal whatever h is, and if we don't have an h, it must be 0. So x can't equal 0. Okay? All right, we do our vertical asymptote first. We have no h, so it's still at x equals 0. So it's going to go here. Okay? Then we do our horizontal asymptote. That's at y equals k. I don't think, is there someone there? Hi. Yeah. Would you know this was for you? You like perked up when you saw it come. Yep, it's for you. Okay. Okay, so k is 2, right? So our horizontal asymptote is at y equals 2. So that's up here. Okay. All right, we all know why those are what they are? You gotta go. I know you don't want to go. I don't want you to go.
Can I take everything?
I don't know. Do you think you're going to be back?
No.
All right, now we got to make our branches, okay? So we count 1, 1 from where these intersect. So here's the intersection, 1, 1, right here. -1, -1, right here. And then we hug the asymptote. Whoops, don't cross it like I did. Don't do that. This is hard to do on the board, but I can do the colors really good on the board, so that's why I'm doing it on the board. Okay? Domain, x can be all real numbers except 0. Range, y can be all real numbers except 2. Okay? Not so bad? Now we're going to mess with A, okay? So we're kind of doing examples where we just have one transformation, okay? So let's look at example 3. X cannot equal, anybody know? What can x not equal? Bless you. X can't equal, what's h? 0. Right? It's always going to be that unless you have an h, okay? All right, then we start with our vertical asymptote. X equals 0 because we didn't move it, right? There's no h value. And then we do our horizontal asymptote. There's no k, so that one's at y equals 0. There's no h, there's no k. But A is 3. So remember what this is. This is a vertical stretch of 3. Okay, now how do I do a vertical stretch of 3? Well, remember our points, 1, 1, and -1, -1. If I vertically stretch those by 3, I'm going to change the y coordinate. Why? Because that's the vertical coordinate, right? So my 1, 1 ends up being 1, 3. And my -1, -1 ends up being -1, -3. Okay? I'm stretching by 3. So from the intersection, I'm going to go right 1, up 1, 2, 3. And -1, -3 right here. And then when you connect, you can see that what we've done is we kind of like pulled the graph away from the horizontal asymptote. That's literally what a vertical stretch is. Okay? Is everyone okay with where I got those 2 points? Okay. Domain, x can't equal 0. Range, y can't equal 0. Vertically stretching does not affect any of these things right down here. It only affects where that anchor point goes on your branches, okay? Okay, if we look at number 4, look, there's a negative in front. Okay, that negative could go in front. It could also just go with the a value. These two things mean the same thing. Any way you slice it though, that's a reflection over the x-axis, right? Our restriction, still x can't equal 0 because there's no h. Okay. Asymptotes, there's no h, there's no k, right? So our asymptotes are where they are by default, right? At x equals 0 and at y equals 0. Okay. Okay, now how do I graph a reflection? Well, go back to those 2 points. Those 2 points are 1, 1 and -1, -1. If you reflect over the x-axis, what was up goes down. What was down goes up, right? So all I'm going to do is change the y-coordinate to be the opposite sign. So it's going to turn into 1, -1. That y-coordinate is going to change to its opposite sign. So that'll be at -1, +1. So do you see how those points, they just kind of flip the quadrants that they're in? Okay? That's how we get a reflection. We just reflect those branches, okay? And then x can't equal 0, y can't equal 0. Okay? All right, so we've kind of taken these transformations one at a time, but now we're going to start to put them together, okay? Are we all okay with that? All right, so I'm going to do 5 and 6 with you, and then you're going to try 7 and 8, all right? So number 5. Let's do our restriction first. Remember, x can't this equation doesn't even exist if x equals a certain number. So x can't equal whatever h is. What is h? It looks like +3, but it's really -3 because it's a shift to the left, right? Okay, so VA, remember that's x equals h. What's h? -3. So x equals -3. That's my VA. Okay. And my horizontal asymptote is at y equals k. Well, k is -2. So that'll be at y equals -2. Okay, this is my HA. Okay, once I get the asymptotes, now I put the points to make the branches. All right, I check, am I vertically stretched? No. Am I reflected? No. So then I find where the asymptotes are crossing, and I count 1, 1 point, -1, -1 point, and then you just hug the asymptotes. Just like that. Okay? And then when you go to do your domain, it's just x can't equal our vertical asymptote. Range is y can't equal the horizontal asymptote. Okay? Starting to get the hang of it? If I promise you, if you do the color, you will get it. I promise. All right. Last one that I'm going to do with you, and then you're going to try too. Y equals 2 over x minus 1 minus 3. X cannot equal h, which is 1. Because think we're shifted right 1. Okay. Vertical asymptote at x equals 1. Right here. Horizontal asymptote at y equals k. My k is -3. So y equals -3. 1, 2, 3. Oops, got my arrows on the asymptotes. Okay. All right, branch time. I have a vertical stretch of 2. So my points are going to be 1, 2, and -1, -2. Because that y value is going to get doubled. So from where they cross, I'm going to count 1, 2. Point. From where they cross, I count -1, -2. Point. And then give it a hug. Give it a nice hug. There we go. Okay. Domain. X is all real numbers except for 1. Range, y is all real numbers except for -3. Okay? And now you just have various variations of that. Okay? All right, so here's what I'm going to do. Because it's one thing to do this with me. Everyone thinks they get it. But it's another thing if you can do it yourself. Okay? So, I'm going to give you 5 minutes to try these 2 examples, 7 and 8. And then there's also this matching section down here. So you're just going to match the function to its description. Okay? We will go over this in 5 minutes. And then you'll be ready for your work, your assignment, okay? Sound good? You got it? You know what you're doing? Looks like you do. All right.